Just to make sure we understand what it means for matrices to be inverses, let's check if these two matrices are inverses. How can we check? Well, if A really is the inverse of B, or B is the inverse of A, then multiplying them together should give us an identity matrix of appropriate size. And of course, in this case, that appropriate size will be 3 by 3. So let's just check if we do get the identity matrix. So we can multiply these either way. So is it true that if we multiply A and B, we get the identity matrix of size 3? Let's just check. So 2, 2, 3, minus 4, minus 3, minus 4, minus 1, 3. I guess I've started writing down B first, and so I guess I'm actually checking if B times A is the identity. If one of them is, then the other one will be as well. So let's just work out this matrix product and see what we get. So taking first column and then sweeping downwards, we get minus 2 times 0, minus 1, so that's minus 3 right off the bat. So, already we can tell, I'm sorry, I'm going the wrong way. This is not right. I was going down the first column, but I'm supposed to go across the first row. So minus 1 plus 0 plus 3 is 1. Okay, so it might be this product might be the identity, so we have to keep going, right? Have to keep checking. So taking this first column down to the second row, we're going to get plus 4 minus 3 plus 4 plus 0 minus 4, 0. Okay, I can't do arithmetic today. And then bottom row, we get 1 plus 0 plus 3. So we're getting a 4. So here we can stop, right? If this were going to be the identity, there ought to be a 0 in this position. There isn't a 0 in this position. So it doesn't even matter what the rest of the entries are. Since it's a 4 here instead of a 0, this can't be the identity matrix. So this is not the identity. And that means that A and B, this one was B, this one was A, are not inverses. That doesn't mean that there aren't inverses for these matrices necessarily, although there might not be. This just means that if there are inverses, these aren't the inverses. All right, so let's look at a slightly different example. What about this matrix? So let's check, is C the inverse of A? So is C the inverse of A? Well, let's check, right? We just have to do a matrix multiplication. Let's do A times C, so minus 1, 1, 0, 1, minus 4, 1, 0, 2. Multiply that by C, 2, 2, 3, minus 4, minus 3, minus 4, minus 1, minus 1, minus 1. Notice that this is almost the same matrix as B. Just a couple entries here are different. When we work this out, so this first column times, okay, so minus 2 plus 4 minus 1 is 1, and then 0 minus 4 plus 4 is 0, and then 2, 0 minus 2, that's 0. Now second column, minus 2 plus 3 is 1, minus 1 is 0, and then 2 minus 3 plus 4 is 1, 2, 0, minus 2 is 0. Things are looking good so far. 3, now going to the third column, 3 plus 0 minus 2. Sorry, I started with the bottom row for some reason and got myself confused. Anyway, I got 1, so this goes down here. Let's start at the top. Minus 3 plus 4 is 1, minus 1 is 0, and then last one, moment of truth, 0 minus 4 plus 4 is 0. All right, this is the identity of size 3, of course. So A and C are inverses. So we could write, instead of writing C, we're now entitled to write A inverse. Or if we didn't like A for some reason, instead of writing A, we could write C inverse. But one way or another, we now know that these two matrices really are inverses because when you multiply them, you get the identity.